Hi, this is Dr. Kraus with a first video in a series that I'm going to call Absolute Arduino Basics. These videos are primarily about training the TAs and instructors for our Introduction to Engineering Design freshman course who may have had zero exposure to electronics or Arduino and are now being asked to help teach this course. These videos may also be helpful to freshmen who are taking the course who are just not very experienced with electronics or Arduino. Because this course is all engineering majors, the Arduino part is maybe really simple if you're someone who's a computer or electrical engineer, but could be kind of intimidating if you're mechanical or PDM. Later I'll create a quick video on how to just download and launch the software in Windows. For now, I'm just doing things from my Mac. So I'm booting up the Arduino software, which is it's called an Integrated Developer Environment, or IDE, and this is how we program an Arduino. But let me just take a minute to talk about what is an Arduino. So this in my hand, you can see there's a US quarter there. This is an Arduino that fits in the palm of my hand. It's maybe 2 inches by 3 inches. This particular one is a knockoff. Arduino, I think part of what makes them awesome is that they're both software and hardware is open source. So anybody can get the software for free, and they've also made the hardware open source, which means anybody can download the schematics. So there are companies out there who are now making these Arduino Unos. A name brand one is like 25 bucks, which I think is a pretty good deal. But you can find decent knockoffs on Amazon or wherever for like 10 bucks. And so this is a Sane Smart $10 Arduino Uno knockoff. This is the processor. It's an Atmel, Atmega something. So a pretty well-known processor that they've built this C compiler for that allows it to do really powerful things. You program it by connecting the USB port to your computer. You got a set of digital inputs here. There's also a built-in LED that's connected to pin 13 that we'll use in this demo to just show how easy it is to control voltages from the Arduino. And then if I can autofocus that a second. We also have a set of, so some of these pins will have some kind of symbol on them. With this brand, it's a little pound sign that shows that those are PWM outputs, so we can use those for analog outputs. And then we've got analog inputs for sensor reading, and then power, ground, 3.3 volts, 5 volts, whatever. One thing that's worth noting, so you can power it from USB, which is a 5 volt input. You can also power it from this plug or directly from VIN. So VIN could be anywhere from 7 to 12 volts, but then it'll get regulated down to the 5 volts. So if you have let's do a quick program demo. I'm going to just slap my USB cable here in this end and over into my laptop, and I'm ready to go. And there should be in here somewhere, if you go to File, Examples, I'm going to Blink, and this is a really basic example that illustrates how Arduino. So basically you have some kind of, in all Arduino, they call them sketches, but they're just programs. You might have some kind of includes or other variable declarations here before your first setup if you're using global variables, which may or may not be a good idea. You have a setup function, and so every Arduino sketch has to have a setup function and a loop function. The setup function runs one time when the Arduino boots, and the loop function runs indefinitely. This is more of an issue for Mac and Linux than it is for Windows, but before you program it, you got to make sure you're connected to the right port, and you should see that it knows you have an Arduino Uno, and on a Mac, 1421 is the USB port on the right, and 1411 or something is USB port on the left. Windows, you generally just have a COM3 or a COM5 or a COM7, something like that, and it's usually finds it. And so that little check mark says that's the port we're connected to. And the board, there's many microcontrollers that can be programmed from the Arduino IDE, and so make sure we're using a Genuino or Arduino Uno. So if I do that, so this little checkbox will just compile the code to verify that it's free of errors. You don't have to do that every time. This little arrow will both recompile and then also upload it via USB to the Arduino. And let me do that again where you can see more of the Arduino. The thing to note is that when it's happening, these two TX, RX LEDs are flashing, saying that I'm getting the code. So all this code is doing is taking pin 13 and setting it high for 1,000, so delay, and then waiting. So first of all, pin 13 has been configured as an output. We do that one time in the setup function, and then in the loop function, we're saying take pin 13 and set it to 5 volts, and then wait for 1,000 milliseconds. Then take pin 13, set it low, wait for 1,000 milliseconds. And because the loop function runs indefinitely, it then goes back up and says high, wait, low, wait, high, wait, low, wait. And we see over here the LED that's already connected to pin 13 is flashing like so. And if I wanted to verify that there's actually a voltage, obviously an LED can't flash without a voltage, but if I wanted to measure that voltage, I could drop some leads into pin 13 and ground and bring over a multimeter and hook that up to ground and pin 13 like so. And you can see that it's going up to 5 volts and back down, and up to 5 volts and back down. And obviously there's a filter in most multimeters, and so it's flopping around and taking a little bit of time as it does that. But that's all it takes for the Arduino to control a digital pin with a voltage, which I could now hook up to a motor or some other kind of actuator, and I'm sending a command with just these very few lines of code. So I think that's part of what makes the Arduino really powerful, is it's really simple to use things like digital write or digital read, and then later we'll learn about analog write and analog read, and I'm very easily interacting with physical signals in the real world. I'll create another short video on how to download the software in Windows and get that working. I mean, Windows, Mac, whatever, downloading the software in any operating system is pretty easy. And then we'll go from there. Thanks.